Hello everyone, myself Kalesh. I am explaining about automata theory and compiled designing assignment on lexical analyzer and recursive descent parser for mini ATC language. This project is developed to understood compiler concepts such as lexical analysis, deterministic finite automata, context free grammar, and parsing techniques. Slide 2. Problem statement. The objective of this assignment is design and implement the lexical analyzer and a parser for a simple programming language called mini ATC. The lexical analyzer reads the input program and divides into a tokens such as keywords, identifier, numbers, operators, and delimiters. For tokenization, the parser checks whether the sequence of tokens follow the structure of the mini ATC language using context-free grammar. The program structure follows begin, statement list, end. The system identifies tokens and verifies whether the program is syntactically correct. If the program is valid, it displays the success messages. Otherwise, it shows the error message. Language specification. Mini ATC is a simple structured programming language designed to demonstrate compiler concepts such as lexical analysis and parsing. Program rules. Program begins with begin. Program ends with end. Keyword are begin, end, int, and print. Identifiers begins with letters. Number contains digits from 0 to 9. Operators include plus, minus, multiplication, division, and assignment symbol. Delimiters include semicolon and brackets. Token design. Tokens are smallest meaningful units of a program. Token classifications are keywords, begin, end, int, print, identifiers, total and some numbers 0 to 10, and operators plus, minus, multiplication, and division. Delimiters are semicolon and brackets. Keywords have predefined meaning. Identifiers represents variable. Numbers represent constants. Operators perform arithmetic operations, and delimiters separate programs elements. DFA for identifiers and keywords. Deterministic finite automata or DFA is used to recognize identifiers and keywords. State states are used. Q0 is a state. Q1 accepts state. Q2 is a dead state. If input starts with letter, it moves the accept state. Invalid inputs move to the dead state. DFA for a numbers. This DFA recognize numbers. State includes Q0 as a start state, Q1 as a accept state, Q2 as a dead state. Only digits from 0 to 9 are accepted. Any invalid characters lead to dead state. Context free grammar and parsing logic. Rules are defined in mini etc. Program produces begin statement list, and statement list contains multiple statements. Statements include declaration statements, assignment statements, and print statements. Parsing uses recursive descent techniques with functions peek, advance, and accept. The parser processes tokens sequentially to valid grammar rules. Invalid test cases. Now let's see the invalid cases. Cases 1. Missing begin keyword result syntax error. Case 2. Invalid identifier result syntax error. Case 3. Missing semicolon. Result syntax error. These errors are detected by the parser. Valid test case. Now let us see valid test case. Case 1. Basic valid program. Output program is synthetically valid. Case 2. Multiple statements. Output program is synthetically valued. These examples prove the parser correctly verifies the syntax. Conclusion. In conclusion, the lexical analyzer and recursive descent parser for mini ATC were successfully designed and implemented. The lexical analyzer correctly identified tokens using DFA and parser verified syntax using context-free grammar. This project helped in understanding practical applications of automata theory and compiler designing. Thank you.